friends, welcome to Basic Electrical YouTube channel. So in this lecture we are going to learn the construction of three-phase induction motor in detail. So it is class number 4. So in class number 3 I explained working principle of three-phase induction motor. After watching that lecture only you watch this lecture, okay? So then you can understand much better. So generally, let's start the topic. Generally, the construction of three-phase induction motor divided into two parts. One is called stator, another one is called rotor. So let's start with first stator construction. So this is the stator construction. Okay. So it will be in a cylindrical manner. So in the stator, slots will be there. See, I'm going to write slots. How the slots are designed. So look at here, you should write like this. Observe how I am going to write. So like this you have to write for this entire circle. Okay. So again you can write like this. Okay, you should write some wedge shaped slot. Okay, like this you complete this entire . Understood no? How to write? After that you erase this part. So before starting you draw two circles, thin lines. Like this you complete this entire part. Okay, got it? So keep writing. Okay students. So like this you write all the slots. So what I written this no? Okay, this is called stator slots. This entire thing is stator. Okay. Inside slot will be there. Okay. So I already explained how to write this diagram. Don't touch this line to the outer circle. Okay. You maintain some gap. Okay. So like that you finish this entire circle. Okay. Now see wherever open is there, na? Open. So there you can insert conductors. Okay. Stator winding or stator conductors. Wherever open is there, inside that you write this conductors. Okay. So like that you finish this entire circle. Okay. For each and every slot. Okay. This is called, see this one is called slot. For each and every slot I am placing the conductors. Okay. And if all these conductors, okay, are arranged in such a manner, it is connected to three-phase supply. So this many conductors connected to R phase, this many conductor connected to Y phase, this many conductor connected to B phase, and then we are giving supply to the stator winding. So when our current flow through the stator winding, it carries current, produces magnetic field in all the windings, and that magnetic field going to be rotate at a speed called synchronous speed. That is also called rotating magnetic field. Okay. So at a constant magnitude of 1.5 times of pi m. This is what we learned in concept of rotating magnetic field. See now, list out the parts. See guys, look at here. So this is called a plate. Okay, stator laminated plate. Got it? So one plate, the thickness of this plate varies from 0.4 mm to 0.25 mm to 0.5 mm. So that will be the thickness of the stator core. Okay. So like that they are joining n number of laminations side by side. See for example, so we can write a diagram like this. You must write only this much. Okay, got it? So what I am writing now, that you need not write. Just understand. See, I am writing like this. Okay, this is one lamination. Now I am taking the same plate, then I am putting behind that, side by side. So if I start doing like that, so a stator core is designed. See, look at here. See, now it is 3-dimensional. So like that, this one lamination you can put side by side together, and finally stamp all the laminations. By stamping all the laminations, then you will get a certain length of the stator core. Then you will get certain length of stator core. Understood? So then, what are the components of the stator core? Okay, the components of stator core are stator slots. Okay, see this one we can call it as stator slot. Okay, what is the function of stator slot? We can put the conductors, we can house the conductors in the slot. Okay, so what is this red color? So this is called stator winding. So this we can call it as stator winding. See, stator winding is a conducting material. Okay, it is made up of either copper or aluminium. So 95% we are using stator winding with copper material. Why means, so the material has to pass in all the slots. So there will be some bending and curvature will be there. So copper is malleable and ductile. We can easily bend the copper. It won't lose its tensile strength. Copper wire, if you start bending like this, it won't cut. Okay, but aluminium, if you do like this 2 to 3 times, it will get cut. Okay, so we are using copper as a winding material for stator. Okay, 90% all electrical machines, they are using copper only, the conducting material. So low current rating, low capacity machines may be done with aluminium as a winding material. Okay, so got it guys? So this part is called slot. Inside that, what we are putting, inside that we are putting conductors. That is called stator winding. Then what about this one? See, look at here, this part. Okay, this part we can call it as stator tooth. Okay, stator tooth. See, this provides mechanical balance. Okay, this is going to provide mechanical balance, means design constraint point of view. See, if I made a wedge shaped, means this conductor will not come away from the slot. Okay, to provide wedge shaped lamination, so we need to do like this. Okay, so that provide a mechanical balance. Okay, got it? So that is the function of the stator tooth, only for balance purpose, to make this slot, okay, in such a way that once we put the conductors in the slot, the conductor should not come away from the slot. So for that purpose, we need an extra construction like this. Understood? So in general, I will tell what you have to write explanation about stator. Okay, so stator is made up of silicon steel lamination. The material is made up of silicon steel lamination. The thickness of the plate, so this is a plate. Okay, this entire part is a plate, one plate. The thickness of the plate is 0.25 mm to 0.5 mm. So like that, by joining n number of laminations, okay, the plate is also called lamination. By joining n number of lamination side by side and stamped together, then we get a certain length of the stator core. So, and finally the stator core will have stator slot, stator winding and stator tooth. So what is the function of stator slot? We can house the stator winding inside the slot. Okay, we can house the conductors in the slot. That is the function of the stator slot. So then about winding. So stator winding is similar to a three-phase winding. Okay, and these windings are displaced by 120 degree with respect to each other and is given to the electrical supply. So when it is connected to supply, it is going to produce a magnetic field. That is called rotating magnetic field. Like that you write. And then another thing is the material used for stator winding is copper. Okay, got it? So then about stator tooth, it provides a mechanical design balance. Okay, in such a way that whenever, suppose if I made a slot like this, okay, parallel slot, okay, this is a slot and this will be the tooth. with this design, the conductor may come out of the slot easily. Suppose if I design like this, if I place a conductor here, this conductor will not come away. Okay. In order to make that, we have to design a tooth like this. So this tooth is making locking of the conductors placed inside the slot. Okay, got it? So like that. So it provides mechanical balance. Understood? So only in design construct, but it is not rotating. Okay, mechanical means people will think something will rise, but only in the mechanical design construct. That's it. Understood, guys? This is about stator. So please pause the video and then copy down only this circle diagram. Don't write this lines and all. Okay. After that, you label all the parts. What I explained, you write it in your own words. So this is about stator construction. Okay. I am going to erase this now, and after that I will explain rotor construction. What about rotor? Where the rotor will be there? Inside the stator. See, this is the stator. Inside rotor will be there. So this one is called rotor. In the rotor construction, again we have two types. That is one called squirrel cage rotor and another one is slip ring rotor. How the construction is done for the rotor? Based on that construction of rotor itself, we have two types of induction motor. One induction motor is squirrel cage induction motor. Another one is slip ring induction motor. So for both the slip ring and squirrel cage, the construction of stator remains same. Okay, got it? So please pause the video, copy down the stator part, and then I will explain rotor part. Okay guys, next we can look into the rotor construction. See, rotor construction has two types. One is called squirrel cage and another one is called slip ring rotor. Okay, we can see this later. We can discuss squirrel cage rotor. Okay, see, this is a rotor. This part is a rotor. So they are going to make a fixed number of holes on the rotor. See, this is also called rotor lamination. It is one plate. Okay, this is a plate or lamination. The thickness of the rotor plate is also again 0.25 mm to 0.5 mm. But in that plate, they are going to make holes. Okay, so let me write some holes here. Okay, like this. So don't write too many. Maximum you write 4 or 5. Okay, write neatly. Copy down along with me. See, you write this and this hole exactly parallel to each other. Okay, with same distance. Don't write one hole here, one hole here. Okay, don't write like that. See, now you can see this is a top way or a front way. Assume that it is a front way. So you can see only the holes. Okay, and this is a plate, circular plate, cylindrical plate. The thickness of this plate is 0.25 mm to 0.5 mm. So like that, they are joining n number of plates, several number of plates side by side and stamp put together. Then you will get a required size of the rotor core. So like this. See, look at here. So I don't want to write there. I am going to write here. Okay. So how the laminations are joined side by side. See, look at here. This is a rotor. Okay, don't copy this one. Okay, I am trying to understand how the rotor is constructed. So this is one hole. Okay. So now you take the back end like this. Okay, this hole parallelly like this, and this one will be like this, and that remaining part will be here. So back end it will be here, and this will be connected back end of this. See, like this. So these are the holes. So this is one lamination. Next laminations they are putting behind this. Another lamination behind like this. And finally they stamped all the laminations. Then you will get a required length of the what? Rotor, required length of the rotor core. Understood? Okay. So I written side wave here. Okay. Now whatever you written here, same thing you write on that side also. This is front wave. At last back end, this is the last laminated plate. Okay. So let me write neatly. Please guys watch the lectures okay, with lot of patience. Definitely it will make you to score good marks in exam. Okay, fine. See, look at here. The word cage. Okay, the rotor winding is done in. Finally, it looks like a cage. Okay. See, this is the first two hole and this is first hole. Okay, join these two holes. Okay, joining these two. See what I joined now. This one is called rotor bar. We can call it as rotor bars. Okay, it is a rod. It is also called a rod with with a different size of thickness and complete rod of a certain maybe 20 centimeter or 30 centimeter. That ready-made rod they are going to insert into the hole. If the rod is inserted here, finally it will come out from this side. Okay, so like that they are going to insert. So finally, once the rod are completely inserted in that particular hole, okay, then the ends of the rod, the final ends, finishing ends, the ends of the rod, it is completely soldered. Okay, soldered, so that it won't come out of this hole or on either side. So they are going to be soldered. So that soldering is nothing but with the help of end rings, with the help of copper end rings, with the help of the copper end rings, the rotor bars are soldered. Okay. So similarly, this hole is connected to this one. Okay. This hole is connected to this one, and back end will be like this. This is a back end connection. Okay, and next connect like this one, connect like this, and this will be the back end. Okay, similarly connect last one. Okay, so there will be so many bars will be there, so they are going to insert in the respective holes. Okay, see now finally the bars are soldered with the help of the what? With the help of what? Very good, end rings. With the help of the end rings, the rotor bars are shorted. See, there is no winding. What you are doing now? Three-phase winding. R phase winding, Y phase and B phase. Not like in squirrel cage rotor. Simply put a rotor bar, a complete, no windings at all, a thick copper rod of desired shape and size. So simply put inside the hole. Once it come out of the rod, extra part you can cut it. Okay, and then finally you should solder with the help of what? End rings. And these are all rotor bars. Okay, this is also copper rod, copper rod, copper rod. So like that, they are finally made the rotor like this. See, everything is shorted. See, this is a rotor bar, so it is completely soldered, and this connection will be around rotor laminated plate. Similarly, another rotor bar is connected here, one more rotor bar. Each and everything is completely soldered. Okay, you cannot add extra resistance to the rotor. Okay, because it is another name for squirrel cage rotor is short circuited rotor. Okay, got it? So another name is short circuited rotor. Okay, short circuited rotor. So we cannot add resistance, okay, to this type of rotor. Why? Means it is short circuited. For a short circuited path, if you connect any resistor, it becomes redundant. See, this is a short circuited path. If I connect some resistor here, okay, if I connect some resistor here, current will flow in this resistor? No, current, because short circuited path will have resistance. Okay, so here resistance will be 0 ohm. If I pass 10 ampere current here, the entire 10 ampere current will flow in this short circuited path only. That current will not come to the resistor. Understood? So that's why it is not possible to add external resistance to the squirrel cage rotor. Why means because it is completely shorted. Okay. So when assume like this rotor, now this ready-made rotor I am putting inside the stator, and finally this rotor is mounted on the shaft. This center circle what I written, that is called shaft. That is not rotor bar, rotor hole, that is shaft. Okay. So this shaft, once I place this rotor inside the stator, outer part will be the stator will be there. Give supply to the stator, it carries current, produces rotating magnetic field, and that magnetic field cut by this rotor bars, rotor conductors, and then EMF will be induced. That induced EMF again circulate current in the windings, and that current produces a rotor flux around the rotor conductor. Now that rotor flux interact with the stator flux. Due to that, it experiences a mechanical force. Okay, it exerts high torque. Due to that torque, the rotor runs. The rotor run, that speed is denoted by N. Okay, so we can see the comparison of squirrel cage and slip ring once both the diagrams are finished. Understood, guys, how to write this diagram? Okay, so cage means, so this line is looking like a cage. Understood? Then why they called squirrel? Okay, in some finally anyhow it is completely short circuited. No, you can connect rotor bar from this hole to this hole. Okay, okay, like this. You can connect like this also. Okay, if I connect like this, then you can see the same pattern of lines you can see on squirrel. Okay, so which is traveling under a tree, no, on tree and roadside, suddenly it will passes. Okay, squirrel. On the body of the squirrel you can see these lines. Okay, parallel lines, slant lines. So they called squirrel cage rotor. Okay, see this hole are parallelly. So internal design is made in such a way that if I insert a rotor bar, the rotor bar will be with some slant angle. Okay, so that is called squirrel cage. So squirrel cage rotors will run smoothly. So what I written first, that is only cage rotor. So it will produce little bit of noise. So in order to run the motor smoothly, we have to put the rotor bars with some angle. Got it? Understood? So internally designing of this little bit complicated. But finally anyhow there is no winding, you can easily connect it. Understood? Squirrel means you should connect the bars with some angle. This one to this one, this one to this one, this one to this one, means that will be back end. Okay, if you start writing everything on front means everything will become crisscross. Okay, it not look good. Understood? But you need not worry, you write only the straight connection. Okay, write only straight connection, means I am putting parallelly. This one is connected to that one, straight connections. Understood? But this type of connection will produce some noise. If you don't want noise in when machine is running, then you make the rotor with squirrel cage. Understood? Okay, we can look into this later. Much more comparison I want to explain, that we can look into later. Next, look at here, slip ring rotor. See, in slip ring rotor, here the rotor construction is having three-phase winding, similar to stator winding. How the stator winding is having three windings, in rotor also there will be three windings. So let me draw the diagram. Please observe how I am going to write. So this is R phase winding, and this will be Y phase, and this will be B phase. Consider like this. R phase winding R1, R2, Y phase winding Y2, Y1, B phase winding B2 and B1, R, Y and B. Okay. So now this entire rotor winding, okay, it is mounted on the shaft. Okay, it is mounted on the shaft. So this is called shaft. Okay, and slip rings are mounted here. Slip rings are mounted on the shaft. Okay, what I am writing now, these are called slip rings. Slip ring and brush assembly. Currently what I am writing on the board is slip ring and brushes. Now you connect R1 starting to first slip ring and solder. Okay. Next to Y1. Look at here. Y1 starting end of Y phase. Okay, let me write neatly. Starting end of Y phase connected to next slip ring, and again that is soldered. Okay, next to B1, B phase starting end is connected to another slip ring. So what about this one? This is R, this is Y, and this is B. And this slip rings are mounted on the shaft. Okay, so this we can call it as slip rings. Okay, slip ring. Well, then what about this one? These are called brushes. These we can call it as brushes. Got it? See now, externally outside the brushes, we can make connection like this. So we can add external resistor. Okay. So I will tell you the reason. What is the application of this external resistance, so that we can connect it here. So let me take, this is position 1 and position 2. Position 1, position 2. Position 1 and position 2. So external resistance R. So I will write external resistance can be inserted. See, in this rotor we cannot add external resistance to the rotor, but in this rotor we can add external resistance to the rotor. Okay. So look at here how the construction will be. Okay guys, look at here. Now this entire thing is called rotor. This entire thing is rotor. Okay, this part is called rotor winding. Okay, the rotor construction is similar to the stator winding construction. See now, look at here. When supply given to the stator, it produces rotating magnetic field. That magnetic field cut by this rotor windings. See, at the moment of starting, see in the brushes. See, rotor runs means slip rings also running, but brushes will not run. Okay, these brushes will have just contact with the slip rings. So just to contact with the slip rings. Got it? So just like this. Okay. See, this is a slip ring. It is running. See, a slip ring is running. This is a brush. Okay, having just contact. That's it. Okay. See now, look at here. So before starting, this variable resistors are there, no, externally connected. This resistor should be at position 1. Okay. When this variable point is connected to position 1, here also 1, then what happens? This in the bottom, I shorted all these terminals, 1, 1, 1, everything is shorted. Then what happens? This resistance is not at all included. Okay. Let me consider 0 ohm is this position, highest resistor is this point. Minimum, maximum, minimum, maximum. Now when I keep this variable rheostat at position 1, then what happened? Everything it become shorted. Then what is the final? The entire rotor winding is shorted. The entire rotor winding is shorted when? At the moment of starting. Okay. At the moment of starting, you keep the rotor winding in a completely short circuited. Okay. At the moment of start, keep the variable resistor point to position 1. So then what happened? Whenever the rotating magnetic field cut to this short circuited rotor winding, it produces an EMF. That EMF circulate current in the winding. That current produces magnetic field. What is that field? Rotor flux. That rotor flux interact with the stator flux, that is RMF, and hence mechanical force is experienced, and then rotor caused to rotate. Once the rotor starts rotating, okay, so slip rings also running, again brushes will going to collected there. So now once the rotor picks up its speed slowly, okay, then we can vary this variable rheostat to middle position now. Now middle position, this much resistance, this much resistance, this much resistance are added to the circuit. Then what happens? Okay, resistance increased. Okay, rotor resistance increases, current will decreases, less magnetic field, less rotor flux, interact with the stator flux. Finally, mechanical experience produced will be less, mechanical force will be lesser, and then rotor speed also get decreased. Okay, rotor speed reduces. So like that, by varying this resistance, okay, the biggest advantage is by keep on varying this resistor, we can control speed of the rotor, and hence we can also control speed of slip ring induction motor by rotor side. Got it? Now please keep it at position 2. Now I varied this one. Now this arrow mark comes here. So then what happens? All the resistance included. Higher the resistance, less current flowing in the rotor conductors. Less current flows, less magnetic field. Less magnetic field, less rotor flux. Less rotor flux interact with stator flux, less mechanical force experienced. And finally, less force, rotor runs slowly. Okay, got it? Again, if you want to more speed means, then keep the position to 1. So at 1, no resistance included. Less resistance, high current flows because rotor will be short circuited. At position 1, high current flows, high rotor flux, interact with stator flux, high force is experienced, and again it runs faster. Okay. Once the rotor picks up its speed, then you can start varying the external resistor so that you can get the required speed what you needed. Okay, got it? So this is how the construction of slip ring rotor. Okay, slip ring rotor construction similar to the stator winding construction. Stator also like 3 windings, here also 3 windings. See, all these windings, there will be rotor core will be there. Okay, how stator is designed, like that rotor will be there, slots will be there. In that slot, they are putting these windings. Okay, so let me write here. This is one slot. Okay, for understanding purpose. See, inside the slot we are putting conductors. All these conductors are connected in series and connected to R phase. Similarly, other side Y phase. Similarly, other side B phase. So finally, all these windings are 120 degree with respect to displaced by 120 degree with respect to each other. Understood? But I wrote like a star connection. What I written, rotor winding is star connected. Okay, got it? But this will happen in the circular rotor core. Their slots will be there. In that slot, they are putting these windings. Got it? Okay, fine, guys. Now, next important thing is comparison between. Okay, compare squirrel cage and slip ring rotor. So I won't write points and all. I will tell generally. You must make it note down in your book. Okay. So first point. Okay, squirrel cage rotor. First point. It is called short circuited rotor. It is short circuited rotor. What we can write here? Okay, first point. Slip ring rotor. Only at the moment of start, only at starting, rotor is short circuited. Okay, got it? In running condition, rotor is not short circuited. See, at starting, we should connecting here, everything is shorted. What are all these points? All are finishing ends. If I join all finishing end R1, Y1, B1, everything becomes shorted, no? When it is happening? Only at start. Okay, in running condition, rotor windings are not shorted. That point you must write here. Okay. Next, resistance, external resistance cannot be added. We cannot add external resistance to the squirrel cage rotor. Okay, but here we can add resistor in rotor winding. Okay, or in rotor circuit. We can add external resistance in the rotor winding. There you cannot, not possible. Because why? It is short circuited. Okay, got it? So next one, number 3, you write speed control. Okay, speed control not possible. Speed control, okay, I written simply n. If you pause the video, simply write n not possible means no meaning. You must know what I say, what I explained, what I wrote here. N is nothing but speed. Speed control not possible in squirrel cage rotor. From which side? Stator side or rotor side? From rotor side. By changing the parameters in the rotor, speed control not possible. Okay, got it? In squirrel cage rotor. Okay, got it? But here, speed control possible. Okay, so I will write here control. Okay, n control means speed control. Okay, speed control possible here, there not possible, because we can have the external resistance, current decreases, speed decreases. Okay, so like that. So next is number 4, constant speed rotor. Constant speed. See, all squirrel cage rotor runs constant speed. Okay, one specific speed it will run, but this one variable speed. Okay, slip ring rotor speed control is possible now. That's why it runs at different speeds. Okay, by keep on controlling in the rotor side external resistor. Okay, got it. So next number 5. 95% industries, 95% of industries, they are using squirrel cage rotor. Okay, so 95% used in industries. But here, okay, 5th point I will write here. Okay, only 5% in industries. That is where speed control is required. They are using this one. Most of the industries machines will run at specific speed. Okay, so they are going to prefer this one, 95% in industries. So next number 6, applications where we can use this type of machines. See, squirrel cage rotor, nothing but squirrel cage induction motor. We are used in lathe machines. Okay, you know the lathe machine which run at constant speed. Okay, lathe machines. Okay, lathe machines. And then milling machines, rice mill, ragi mill, okay, milling machines, and then drilling machines, okay, drilling machines used by electrician to make a hole on the wall, that is called a drilling machine. And the same thing used by building construction workers, okay, so to drill the wall with a larger hole or smaller hole like that. So that machine runs at specific speed. Okay, that is called drilling machines, etc. Okay, and we can use this in fans also. Fans means in our home ceiling fan will be there, no? Not that fan. Okay, in theaters and all, big fans will be there on side of the wall. Okay, so those fans run by motor. Okay, induction motor. So supply is given. That will going to spread the air with long distance, okay, for a longer space. So this fans nothing but fans used in theaters and shopping malls like that. Okay, big fans. What we are using in our home, that is induction motor, but very smaller size. Okay. So next, fans, blowers, fans and blowers, etc. like that. Then where we can use slip ring rotor, 6 point. There 6 point is where you are using. Here you can use this rotor in lift. Okay, lift, cranes, lift elevators, okay, and then conveyors, lift elevators, conveyors, etc. Lift elevators, conveyors and excavators. Okay, there also we can use this one. Next, look at here, another point, coming to the torque. Okay, so it's going to produce medium starting torque. Okay, squirrel cage is going to produce medium starting torque, which cannot be controlled. Okay, which which cannot be controlled, Then what about this side? High starting torque. Okay, it produces high starting torque. And it can be controlled. Okay, high starting torque and it can be controlled. We can control this torque and it can be controlled. See, what I am writing on the board is not clearly visible. Okay, listen, and what I am explaining, listen that and write it in a correct sentence because no space here. Okay, next, like this, you try to make a differences around 5 to 6 differences on both the sides. So that is sufficient. Suppose in exam if they ask, explain slip ring rotor means, draw this diagram. Whatever the points are written on squirrel slip ring side, that one you write. Don't write that one. Okay. Next, suppose if they ask the squirrel cage rotor, explain squirrel cage rotor construction of a 3-phase induction motor. You draw this diagram. Whatever the points are given, you simply list out all these key points. That is sufficient. Okay. Sometimes if they given compare squirrel cage and slip ring rotor, then write only the points. Then don't write diagrams. If you return diagrams, it is added advantage. But evaluator will not look into that. Only they will see the points. If they ask constructionist, then only they are looking into the diagrams. Without writing diagrams, don't write these points. Okay, got it? Understood? So, like this, several points we can write on both the sides. One more important point is here, this side. See, the rotor poles in squirrel cage rotor, rotor poles adjusted itself for stator poles. Okay, rotor poles adjust. Very, very important. Adjust itself for stator poles. Rotor poles adjust itself for stator poles. Okay, but in slip ring rotor, okay, we have to design the rotor. Okay, we have to design the rotor in such a way that rotor poles should be equal to stator poles. Okay, that is important. Rotor poles should be equal to stator poles. Got it? So if the stator pole is 10 means you should design a rotor in such a way that the rotor poles should match stator poles. Okay, got it? Rotor poles and stator poles both should be equal. But here you need not to design at all. The rotor itself adjusted to stator poles. If the stator pole is 20, rotor poles are adjusted to 20 poles. Understood, guys? So like this, so many points are there. Okay, watch the videos with a lot of patience because we're going to provide good marks in university examination. Okay, if you're not following your college lecture and not in YouTube lectures also means it will be a problem. You cannot study all these things once exam timetable announced. Okay, not possible. Okay, then you have, because why means you have lot of calculations in the mind and time is very less and you want to score highest marks in less time. Not possible, because entire semester if you're not putting hard work, in 3 days if you start putting hard work means, so it will give a negative result only in the end. Okay, you may get pass also or you may get fail also. Finally, your calculations will not reach your expectations in real time exam. So don't create such situations. When you are free, you can prepare the contents, okay, well in advance. So that is a better option. Understood, guys? Any other points is there I want to tell means so I can remember? Okay, enough. You can refer any some books, okay, textbooks for given in your VTU syllabus copy. Refer those books. So and then start writing the points. Okay. Instead of that, I refer the same books. I will study the prescribed textbooks and I will give the content like this. Okay, guys. By here we can stop this video. In next lecture, I will be explaining the significance, concept of slip and its significance. Okay, significance of slip and some induction motor terminologies. Okay, that is very much important to solve problems on induction motors. So have a nice day. Take care. Meet you next lecture. slip and its significance. Okay, very important lecture. Bye bye.